Okay, welcome. Good evening. Welcome to our summer stargazing event. Thank you for your patience. We had to reschedule this program due to the weather. We had that tropical storm come through and not only drenched us, but also knocked us offline as well for more than a week. So we're going to do a little stargazing with you tonight. So we're glad that you are here. Before we get started with our program, I just wanted to make you aware of some of the upcoming programs that we have online for the Newark Museum. On Thursday, it's August 20th at 12 noon, we have a Lunch and Learn program. We have an artist, Dalia El-Sayed, who will be talking to us about her paintings and sculpture, which sounds really interesting. For those of you who like evening programs, take a look at our jazz program on Friday night at 7 p.m. Also, don't forget on Tuesday, August 25th, if you like our astronomy programs, we have another Ask an Astronomer program coming up at 12 noon on August 25th. And that one is going to be all about black holes, really interesting topic. And looking a little bit further into the future, we do have a community day coming up Saturday, September 12th. We have a Dino Fest. We're going to be talking about dinosaurs and fossils. They're going to take over the museum, at least online, and we're going to give you a little virtual celebration for the whole family. And so please join us on September 12th. Tonight, we're going to have as I mentioned, we're going to have our stargazing program. As we begin this program, we pause for a moment here to join our museum supporters, Susan and Jason Anderson, in remembering their daughter, Kia June Anderson, whose love of the stars and Camp Newark Museum has touched our museum community. We just finished up this year's Camp Newark Museum programs, and that was very successful. And so we remember Kia. This one is for you, Kia. And so we're going to introduce some of our panelists here, which you'll see kind of moving in and out of view because they are in the dark, quite literally. We have Mark Zdarsky, who is the observation chairman of the committee for the North Jersey Astronomical Group, one of our local astronomy clubs. And so, Mark, thanks for joining us. And
my pleasure.
And so we also have Omar Radwan from the club, and he's one of our newer members of the club. And so say hello, Omar. And both Mark and Omar have their telescopes set up outside right now. And the weather's been kind of touch and go at this point. We've had clouds kind of coming and going this afternoon, and they kind of cleared off a little bit for us, and hopefully they'll stay away. And we'll get a good view of the sky here. And so they've got their telescopes set up. Before we go to the telescopes, though, I'd like to show you a little bit about the nighttime sky. I'm going to give you a little tour here of the nighttime sky. And so let me put up the northern sky. We're going to face north. We have our sky set up for tonight at around 9:30. And so looking north, this is the correct position for our stars right now. And so as we look towards the north, I want to show you some of the common features here of the northern sky. This is a good place to start because a lot of people know the shape of the Big Dipper. And so if you look here in the northern sky, see if you can spot the 7 stars of the Big Dipper. I'll give you a hint. They're getting low over in the northwest part of the sky. And so if you follow my cursor here, my little arrow, look right over in this area, and you will see that this group of stars right here, there is the famous Big Dipper sitting right here. You've got the 7 stars of the Big Dipper sitting right here in the northern part of the sky. And so this is the famous Big Dipper. It's getting a little bit lower now that we are getting towards the end of the summer. It's getting lower over in the northwest sky. And so you'll spot it right over in this area. Keep in mind that this is part of a larger constellation. This is really the constellation of Ursa Major, otherwise known as the Great Bear. And so people like to imagine these stars as a bear over here in the northwest sky. And you can see he's kind of almost walking along the horizon around 9:30 this time of year. And so there's Ursa Major. And this pattern of stars comes in really handy because it can help us find our way around the sky. And so, for example, you can use this to help you find the North Star. So take a look at these two stars right at the front of the Big Dipper. Got them right there. And if you draw a straight line right through those two stars, follow that line out, and you'll run into this star right here. And so this is the star Polaris that we call Polaris, or just North Star is our nickname for it. And that's what most people call it. And you can see that it is due north of us. No matter what time of year it is or what time of night, the North Star is sitting right there in that part of the sky. The North Pole of the Earth is pointing very close to that star, and so it doesn't seem to really move very much. And you can see it is also part of another little star pattern here. We've got the 7 stars of the Little Dipper sitting right there, otherwise known as the constellation Ursa Minor, the Little Bear, but there's the Little Dipper sitting right there. And so we've got the Big Dipper in the Ursa Major, Little Dipper in Ursa Minor, with the North Star at the end of the handle. So if you want to figure out your directions in the north, that's where Polaris is right there. That helps you find north. By the way, one thing I like to point out in the summertime sky is a constellation that technically is visible all year round, but the summertime is the best time. And you can find it by looking for some faint stars in between the dippers. And so if you look in between the dippers, you get this curve of stars that wraps around the Little Dipper and goes up high in the northern sky. And you've got this little box of stars way up here. This is the constellation Draco. And this is Draco the dragon. And so during the summertime, his head is real high up in the northern sky and easy to find, and his body sneaks around there in the northern part of the sky. And so there's a basic view of the northern sky there, and this northern summer sky. But let's turn our attention a little more to the south. We're going to turn around here and face the southern sky, because we've got a really nice pattern very high up this time of year in the southern sky. If we face south and look almost up overhead, we've got some bright stars here. You can see the head of Draco poking out there in the north. But if you look high overhead, you'll notice this is really quite obvious. We've got 3 very bright stars here in this part of the sky. And they make a nice big triangle here. We've got this big, nice triangle of stars. We've got a very bright star right here. And that's the star Vega. And so we have these 3 stars that make up this large triangle here in the nighttime sky. We've got these 3 bright stars here. Vega, Deneb, and Altair make up that summer triangle. Rosa reminds me of a big slice of pizza here in the summer sky. And so this is a nice prominent group of stars, good prominent group of stars to know. You use this to kind of hop off and find other constellations here. And one of the constellations we'd like to take a look at next has a really nice telescopic object here. And so this is the constellation of Hercules. And it's right next to that summer triangle. You've got the triangle sitting right here. And right next to it, we've got this little box of stars. And that's the body of the constellation of Hercules. And so this is Hercules, or this is how sometimes traditionally it's drawn, with his head down towards the south. I like to actually imagine it the other way around, with his head here and his shoulders here. And right under his armpit, there is a really massive star cluster, and it is known as M13. This is M13. It's a really big star cluster. And so we're going to take a look at this with one of our telescopes here. Mark, are you still focused on M13?
Yes, I am. I got it in view right now.
Got some clear skies? Okay. I'm going to stop sharing my star map here, and you can switch over to your telescope. And we'll take a closer look at M13. It's right there in the kind of armpit of Hercules.
Okay, here we are.
And so there we go. So here's a live view of this object. We often refer to these star clusters and nebulas and things like that. We like to refer to them as deep sky objects, because they're not close to us. They're pretty far away. And so this is high up still high up in the southern part of the sky. You face south, look up, look for that summer triangle, and then you can look towards Hercules right next to it. And this is under his armpit, this little fuzzy spot, and it's pretty bright. You can usually very easily spot it in a pair of binoculars here. And but this is through as we said, a live telescope view. What size telescope are you using there, Mark?
This is a Celestron 11-inch.
Yes.
So yeah, it's pretty big.
So there's an 11-inch diameter, so it's almost a foot in diameter here. And we've got a nice view of this cluster now. M13 is what we call a globular cluster, and you can see why we call it a globular cluster. It's round. You get this big globe of stars, and there are several hundred thousand stars in this little area of the sky. So it's very densely packed here. And it is also, by the way, known as M13. And you'll often hear that in astronomy. A lot of astronomers will refer things by catalog numbers. And M stands for Messier. Charles Messier was a French astronomer, and he cataloged a bunch of very bright star clusters and nebulas and things like that. So there are a lot of Messier objects out there, and this is one of them. This is the number 13 in his catalog, so that's why we call it M13. And it's pretty far out there, about 25,000 light years away from us. So it's pretty far out there, but it's a big cluster, and it's very easy to see in small telescopes, and as I said, even in binoculars. Actually, if you have really clear dark skies, you can actually see this naked eye too, if you know where to look in that sort of little armpit area of Hercules.
The Adirondacks, you can. Yes.
Right. Yeah. If you're really far away from city lights, you can get a really nice view of the whole sky, but this stands out pretty well. Okay. So I think we should go back to the summer triangle. Again, we're facing south at this point. Let's go back to the summer triangle. Nice. And we wanted to take a look at another object in the constellation Lyra, I believe. Now, Omar, are you focused on something at the moment? Are you lined up on an object? Looks like Omar is. Hi, Omar. Can you hear me?
Sorry about that. Still working on. I had a problem with one of the cameras and trying to get the telescope lined up. So.
Okay, sure. Well, we can come back to you for another object here. Mark, do you want to? Can you get the ring nebula in for us?
Sure. Just give me a second here.
Yeah, and while you're doing that, I will share my screen again, and I'll show you the next object that we're going to look at here. Let's go back to our star map.
Telescope making noise now when I move it.
So let's go back to that summer triangle. We're looking south, very high up, almost overhead at this point, as we're facing south. And we've got that summer triangle there. And the bright star Vega here is in the constellation Lyra, the Harp. And so this is where our next object is located. And by the way, if you do have any questions for us as we're going through our little sky tour here, for those of you who are joining us on Zoom, you can use the little question and answer feature, the Q&A feature at the bottom of your screen. You can click on that and answer some questions for you. So let me zoom in here a little bit. You got it? Okay,
yeah, I'm just going to get it in the center of the screen here.
Okay, while you're centering, I'll show people where the constellation Lyra is. Lyra is the harp, and you see this little box here represents the harp. So you have to imagine some strings stretched across that frame there, and that forms the harp. And the object that we're looking at is located between these two stars at the bottom of the constellation Lyra. And so right in this area, about halfway in between and a little bit to the north and right in between those two stars, that's where we're going to be pointing. Mark is going to be pointing his telescope, and we are going to be looking at a very interesting object called M27, otherwise known as the Ring Nebula, and a really fascinating object there. So have you got it centered yet, Mark?
Yeah, I do.
Okay. Let
Yeah,
me stop my sharing
share
here.
my screen here.
Yeah.
Get back on. Okay. Can you guys see it?
Ah, yes. Very nice. So
We're starting to stack the image now. So as it goes, one image is getting added to another and to another. It's going to get better and brighter. I think you can
right.
even see the central star here tonight. We have a
Yeah.
decent night.
Yeah,
Yeah.
that's a very good sign of a clear sky. And so what Mark is describing here is the software that he's using with this digital camera is stacking images. It's a really powerful technique that is used in astronomy, both professional and amateur astronomy, where you take short little exposures. Right now, these are what, 20 seconds long, Mark?
20, yes.
Yeah, about 20 seconds long. And so taking short little exposures and stacking them up. And the more that you stack, the better your image quality is going to be. And so you can see this little ring here. This is M57. Remember the object we just looked at, that big star cluster, is called M13. This is M57, the famous ring nebula. And so this is a really nice summertime object, much closer to us than M13, as I mentioned, was 25,000 light years away. This is about 2,600 light years away, so almost 3,000 light years away. And this is a really interesting object, especially for us. We live around a sun-like star. And so what will our star look like in the far future? When it runs out of fuel, it might look like this. This is a nebula. Remember, nebula is a big cloud of gas and dust. This is a nebula left behind by a sun-like star that has reached the end of its life. We actually did a program recently about the life cycle of stars. Just last month, we had an Ask an Astronomer program where we talked about all the life cycle of stars. You can check that out on our Facebook page. We have the video recorded there. And we talked about how once you reach the end of the life of a star like the sun, it doesn't explode. It kind of goes out with a whimper. It doesn't go out with a bang. And when it gets to the end of its life, it sheds its outer layers. And so this is what you see happening here as you look at this old star. The gases have been shed off, and you've got this big ring of gas. And so this star died about 1,500 years ago. And so over time, over the last 1,500 years, this gas has been expanding, and this is what it looks like to us right now. Early on, when it was first discovered back in the 18th century, when astronomers looked at this, their telescopes were pretty small at that point and not very good quality. And so these nebulas look like little bluish green discs to them. And one astronomer, one of the early astronomers, described it as it looks like a little planet in the sky. And so that's how they became known as Planetary Nebula. And it's a bit of a misnomer, though, because it really has nothing to do with planets. It's really the death of a star. And so here is the beautiful Ring Nebula. Again, if you have any questions about this object or any other objects, we can talk about that. Actually, I'm glad I checked because Mary asked a question. Can you tell how much the ring has expanded since the star died? And yes, we can measure that. Right now, it's about 1.3 light years across. And so that is a little bit larger than our solar system. So that cloud of gas, or the gas that was part of the star, blew off and has expanded to a size that is bigger than our solar system. And so that's what we're looking at here right now. So that's pretty amazing. I think what we'd like to do is show you another planetary nebula here. There's also a really nice nebula just to the south of this, still inside the triangle. It's called the Dumbbell Nebula. And so if Omar or Mark, either one of you, can find for us the Dumbbell Nebula, we could take a look at that.
I can definitely do that. Let me just save that image. It actually
Sure, yeah,
nice.
if you want to, yeah, it came out nice if you want to save that. That's good.
Yeah,
Yeah.
Kevin,
yeah.
Yeah, the roster right now is not operating the way I want it, but the evolution, I have it on Jupiter. As
Oh,
a,
okay. Well, let's take a little side trip. Why not?
Okay.
If you've got to
I'll
focus, let's take a little side trip
I'll
and
go
go
to the
take a look at
nebula
Jupiter.
while he goes
Yeah,
to
what?
Jupiter.
Yeah, if you could go to M27, we'll switch over to Omar with Jupiter. Now,
Yeah.
um, let's take a look at a close-up shot of Jupiter.
so this is
And
not, so just to give you an idea, this is not stacking. This is
okay,
actually as we are seeing it through the camera.
ah,
Seeing condition is not that great, but there is some slight detail in the bands. But go ahead, take it away, Kevin.
sure. Yeah, no, this is a live view of Jupiter. And you can see that it does look a little funky. And yeah, that's what planets look like when they're low in the sky. What you're looking at is turbulence, air turbulence, not on Jupiter, here on Earth. You're watching warm air. Today was not a very hot day, but it was warm and humid. And so the ground is heated up quite a bit. And as the sun is set, well, the ground will release that heat and you get a lot of turbulence. And so that's what you see when you see stars twinkling in the nighttime sky. That's what causes that, is the atmosphere here on the Earth, the turbulence in the atmosphere. And so as Omar is looking through his telescope at this planet, you can see this kind of boiling a little bit. It almost looks like you're viewing it from the bottom of a swimming pool here. And so, but you can see some details. Now, what size telescope is this, Omar?
That is the 9 1/4 evolution.
Okay, so a 9 1/4 inch telescope that we're looking at here. Both of these telescopes, by the way, that we're looking through are reflectors, or reflecting telescopes. This one is a 9, Mark's is an 11 inch. And so as you look at Jupiter, the most distinctive thing about Jupiter is its bands. Notice that there are those horizontal bands going across the face of Jupiter. And that's the atmosphere of Jupiter that you're looking at right now. And so you see those nice colored bands across the face of the planet. Now, I neglected to look to see what time the great red spot is visible, but it's not always visible. Some people are surprised by that when they look at Jupiter in a telescope. They see the bands, but they don't necessarily see the great red spot. Well, remember, the planet is spinning. It's turning just like the Earth is, but it spins a lot faster than the Earth. It's turning once every 10 hours, which is pretty amazing. You got this giant planet, 10 times wider than the Earth, and it's moving and doing a full 360 rotation in only 10 hours. But that means that the great red spot is not always facing us. And so you got to go and look it up to see when is a good time to look for it. So there's a nice view of Jupiter. Let's see. We also had a question about the colors. Susan asks, are the colors that we're looking at here, are they enhanced by the software, or are they what we might actually see? Well, certainly with a bright object like Jupiter, this is pretty close to what you'd actually see. A bright object with our eyes, if you look directly through the telescope with an eyepiece, you'll see some colors. But for a faint object, let's say if you're looking at a faint nebula like M27, the ring, or some of the other nebulas, those are kind of faint, and so those colors you really would not see to the eye. Those nebulas often look able to have a gray-green color. But since we are using digital cameras, the digital cameras are picking up the colors much better than our eyes are. And so it's not really, in this case, with these kind of raw images, we're not really enhancing the color, but the cameras are much better at seeing the colors than our eyes are. And so this is fairly realistic view of Jupiter. Someone asked about how big is Jupiter. Analia, if I'm pronouncing that correctly, asked how big is Jupiter. Good question. Think about it this way. If Jupiter was a big gumball machine, you could fit about 1,200 Earths inside of it. So its volume is huge. It's the biggest thing in the solar system besides our sun. And so it's a big planet, biggest planet in our solar system, but certainly not the biggest planet we see out there. We see planets orbiting other stars, extrasolar planets that are even bigger than Jupiter, many times bigger than Jupiter. Mary asks a good question about pollution. Does pollution affect these images that we're looking at? And oh yes, very much so. The curse of every astronomer is light pollution, not air pollution, but light pollution, remember, is light scattered from street lights, and that's what really does ruin our view of the nighttime sky. And so that affects astronomy certainly. But pollution, air pollution, yeah, sure, that can affect astronomy too. When you got a planet down low like this, smog can really ruin your view of the sky. The sky gets very hazy and it gets very thick, especially in the summertime, like it is now with the humidity in the air. Sometimes the sky can get very thick and really degrades our view of the nighttime sky. Let's see. We also had a question. Good question from Robert. What location are these telescopes viewing from? I forgot to mention that. Right now, Mark and I are out in Morris County, so we're towards the center of the state. Omar is in Essex County, and so Mark and Omar have the telescope set up at home, and so that's where those telescopes are viewing from. So they're seeing the same sky that you are out your window there. And a couple of people, Janik and Patrice, asked about other planets. Are there other planets visible? Patrice is wondering whether or not Saturn would be better. Well, Saturn, I think, is a little bit lower in the sky. Maybe we'll try for Saturn a little bit later. What do you think, Omar? Can we hit Saturn?
Actually, that's going to be my next target, considering.
Oh, okay. It's pretty close by, and that's the neat thing about Jupiter and Saturn right now is they're very close. Actually, let me share my view while you're repointing the telescope, Omar. Let me share my screen again, and I'll show you where these two planets are located so that you can find them on your own. And so let's zoom out. Remember where we've left off, facing the southern sky. So we have the summer triangle, we've got Hercules. But if we look over to the southern and southeastern sky, below the triangle, almost actually right now, just right below the triangle, if you look over to the southeast and southern sky, down low at this time of night, you've got Jupiter and Saturn real close to each other. And that's unusual. This only happens about once every 20 years. And that's going to be in the news later in the year. Jupiter and Saturn are heading for a conjunction. In other words, they're going to be very close together in the sky. And that hasn't happened in a really long time. But for us, that conjunction occurs in December. But the problem is that if you wait all the way to December to look at Jupiter and Saturn, you're really going to miss out because that conjunction happens really low in the sky when you get to December. They're setting over in the western sky. What's the best time to look at Jupiter and Saturn? Right now. Right now is great because they're starting to get up high in the sky and they're still reasonably close together. You can see them close together in a telescope. And so that's what Omar is going to do. He's going to slide over from one planet to the other. And so Jupiter and Saturn are really the only two bright planets that we can see in the evening sky right now, in the early evening anyway. And so there's where Jupiter and Saturn are. And in fact, actually, while Omar is getting focused, let me zoom into Jupiter here just to show you the moons, because we had a magnified view of Jupiter there and we didn't really see the moons. And so here's a magnified view of Jupiter. There's the stripes that we were showing you in the live view. But the moons of Jupiter are really big and they're really bright, very easy to spot. You can see Europa and Callisto next to each other, Io and Ganymedes. So you've got the four large Galilean moons named after Galileo, we had as a guest for one of our recent programs. And so these are named after him, and they're really easy to see. They're so large that you can see them in binoculars. And you can watch them actually move, which is really awesome. You can look at them, come back a couple hours later, you can see they've shifted position. So it's quite interesting to watch those moons orbiting around Jupiter. Let's see.
Kevin, can I cut in for a second?
Yeah, sure. Go ahead.
Just so you know, I'm about to lose my sky. The clouds are coming in.
Uh-oh.
I do have M27. I'm not sure how long I'm going to have it for.
Okay.
Just so you know.
Omar, should we switch to the dumbbell and then go to Saturn?
Yeah, go ahead, because it's going to take me a minute to get
Okay,
in.
so Omar is still lining anyway. So yeah, let's jump over to the dumbbell. And,
Okay. I will share it. Okay, here we go.
By the way, and this is related to our object that we're looking at right now, also related to the Ring Nebula. Adrian asked a good question. He asked, what is the average life of a star? That's a little bit difficult to generalize, but because there are a lot of different sizes of stars, big stars, they can live very short lives, which doesn't seem to make sense, but they're big, they're huge, they're massive, they burn their fuel really quickly, and they only live sometimes, in some worst case scenarios, only a few million years. And you have really tiny stars, well, they're burning their fuel really slow, and they can last billions and billions and billions of years. Our sun is neither large nor small. It's kind of a medium-sized star. And so it will live about 10 billion years, in other words, 10,000 million years. And we're about halfway through the life of our sun. And as I mentioned, as it reaches the end of life, it'll end up like a planetary nebula, either like the ring or like this, the dumbbell. This is M27, the dumbbell nebula. You can see why we call it that. It looks like a dumbbell weight that you would lift at the gym. And so this is a really nice object. Technically, it's in the constellation Vulpecula. It's right in the middle of the triangle, but it's actually closer to a cute little constellation called Sagitta. And Sagitta is the arrow. And it's a little tiny constellation right in the southern part of the summer triangle. And so this is near Sagitta, fairly easy to find. It's not quite as bright as the Ring Nebula, and it's a little bit bigger though. This is about 3 light years across, and this is quite a bit older than the Ring Nebula. This is about 10,000 years old, and so it's been expanding for a very long time. And so this is a star that again has lived and reached the end of its life. It's, as we said, a planetary nebula, about 10,000 years old. It's about 3 light years across, and so this is significantly larger than our solar system. But our sun may eventually end up like this or like the Ring Nebula. The reason why the Dumbbell Nebula looks so much different than the Ring Nebula is that when we're looking at this nebula, we're looking at the equator of that star. And so you see this bulge of gases coming out from either side of the equator. So you imagine kind of the equator of that star going right down the middle of this view of the dumbbell. Whereas the Ring Nebula, we're probably looking down on one of the poles, and so it looks more circular. So these planetary nebulas can really look quite different depending on how we're looking at them. So really a very nice object. Also something that you can spot in binoculars if you have really dark skies, you know. So that's a nice view of the dumbbell. Shin asks, speaking of planets, Shin asks, how far away is Jupiter? Good question. Remember that in the solar system, we have the Earth, we have Mars, and we have Jupiter. So it's the 5th planet from the sun. What's the best way of thinking about it? It's about 500 million miles away from the sun. Saturn is close to a billion, not quite that, but close to a billion light years from, billion miles, not light years, sorry, billion miles from the sun, and Jupiter is about half that. But it's pretty far out there as far as we're concerned. And so Jupiter is a big landmark in our solar system. It's a really big planet, and takes about about 12 years for it to orbit once around the sun,
Right.
Compared to 1 year or 365 days for the Earth. Speaking of binoculars, Shilpi asks, how much can I see with binoculars? And she mentions, I guess she has binoculars that are 10 by 40. When you're talking about binoculars, the first number that you see, that's the magnification. And then the second number you see is the diameter of the lens. And the bigger that lens is, the more you're going to see. 40 millimeter binoculars is really kind of considered a bit substandard for astronomy. You can see a few things. There's certainly some bright objects that you can see with binoculars that size. M13, for example, you should be able to pick out in a 40 millimeter binocular. But something that's more like a 50 millimeter, let's say an 8 by 50 or 10 by 50 binoculars, is considered a good size to view a number of different things in the nighttime sky. Okay. Someone asked if we could see M17. We hope so. That's on our list. That's on our hit list for tonight. So hopefully we'll get to that. Let's see. How are we doing on Saturn, Omar? Did we have, do you got Saturn?
I'm actually ready. So.
Oh, great. Yeah. If you go ahead.
Switch. Yeah.
Yeah. So say goodbye to the Dumbbell Nebula. And let's move on to Saturn, which is always a treat. It's always an amazing object to look at in the sky. And so here we have a view of the planet Saturn. You can see the planet. You can also see those rings sticking out from either side. And we've got a bit of a fuzzy view. Saturn is still at this hour a bit low in the sky, and so that atmosphere is causing us to see a little bit of fuzz. As it rises up, it generally gets clearer. You generally get a clearer view. And so a really nice view of the rings right now. And the planet, you don't usually see as much detail on Saturn as you do Jupiter. Not only is its atmosphere much quieter than Jupiter's, but as we just mentioned a moment ago, it's almost 1 billion miles away from the sun. So it's pretty far away from us. And so we don't get to see quite as much detail as we do on Jupiter, but still really a fascinating planet to look at. And some things to look for here, it's a little bit too fuzzy to see, but sometimes when you look at the rings through a telescope, you'll see a little gap in the rings on either side. There's a little gap there, and that's a real gap. It's not like it's an optical illusion or anything. There's a gap in the rings. There are actually several gaps, but the largest one can be seen in small telescopes, and it's called the Cassini Division, named after a French astronomer who first discovered it way back in the 18th century or 19th century. I forget what date he discovered that, but that's the Cassini Division. And we sent a spacecraft, NASA as a spacecraft to Saturn there, and that was called the Cassini spacecraft in his honor. And so that's a view of Saturn there. Let's see. We had a couple of other questions here. Someone asked about how can you tell the ages of the stars? We were talking about the planetary nebulas. We were talking about how stars reach the end of their life. And it's not an easy question to answer succinctly, I think, but basically what we astronomers do is we take a look at the brightness of stars and we try to estimate their masses. And what you can do is you can plot those brightnesses and masses, and that gives you an idea of how bright they are and where they are in their life. There is a famous diagram in astronomy that's called the Hertzsprung-Russell diagram. And unfortunately, I don't have one handy, but if you Google that, Hertzsprung-Russell diagram, that shows you the path. It can show you the path of how stars live their lives. And so it's really a fascinating topic. And again, as I mentioned, we just did a video about that recently. If you go to our Facebook page and look at our Ask the Astronomer programs, the one from last month, we talked about the life cycle of stars, and we explained a little better, I think, there. Okay. So there is Saturn. And so I think, let's see, where are we?
We lost the connection for a while.
Oh,
so
we lost it? Okay.
Yeah, I think we're back now, but just wanted to let you repeat the last thing.
Okay, where did we leave off? Where did you lose us? We were just talking about Saturn. Did you hear the whole part about Saturn? We're looking at this planet. It's almost 1 billion miles from the sun. You've got these beautiful rings to look at. These, it's kind of looking a little fuzzy here because of the atmosphere. Saturn is a little bit low at this hour. And you can see these really nice rings. Something to look for here is to look at the rings very carefully. And sometimes you can see a little gap in the rings. And that's a real gap called the Cassini Division. And it's a gap of the rings caused by the gravitational pull of the planet and its moons and that sort of thing. And it's visible, often visible in smaller telescopes, let's say an 8-inch or 10-inch diameter telescope. You should be able to pick that out, that famous Cassini Division. It's a really nice feature to look for. If you see it, you know you've got some pretty good sky conditions. The sky is pretty steady and clear. So a beautiful view of both Jupiter and Saturn. These two planets, as I mentioned earlier, these are the only two bright planets that we have visible here in the early evening sky. So let's see. So guys, are we ready to move on to another object here?
I
Mark?
might have a treat for you before I lose my sky.
Oh, sure. Yeah. If you want to jump.
I am trying to get to Pinwheel Galaxy, but it's just above a tree.
Okay.
Just bear with me a second here.
Let's give it a shot, because we did want to show people a galaxy tonight. In the meantime, while you're doing that, let me take a look at our questions here. Elsa asked, does the human eye see actual colors of the objects? We mentioned that a little earlier, that yes, for some objects, for bright objects, you can see the actual colors, but for dim objects like galaxies and nebulas, our night vision is not very good and we do not pick up the colors, but the cameras can. The cameras will pick up those faint colors. Janek also asked a question about how far is the Big Dipper? Well, kind of hard to tell you. When you talk about whole constellations, you can't really tell the distance of a whole constellation because those stars that are part of the constellation are not all the same distance. Some of them are very close to you, some of them are very far away. And so you can't really tell. Now, there are quite a couple of the stars in the Big Dipper that are fairly close to each other, but I don't recall off the top of my head how far some of those stars are. They're not very close. They're not very close to us, maybe a couple hundred. If off the top of my head, I'd say a couple hundred light years away from us or so, if I had to guess. So speaking of planets, we just finished with Saturn. Someone asked about Pluto. What's Pluto's status? Is it back to being a planet again? Officially, no. It is a dwarf planet. Remember that if you took Pluto and stuck it onto a map of the United States, you could put one end on Newark, New Jersey. The other side would not reach Denver. Pluto is only about 1,500 miles across. It is super tiny. Not only is it not as big as the moon, it's not even big as the United States if you stick it on a map. So it is a very small object, and so we do refer to that as a dwarf planet. And there are 5 known dwarf planets in the solar system, though there are probably many more than that have yet to been really recognized yet. Shilpi also asked another question about the planets. Is Mars and Venus still visible in the pre-dawn sky? Yes, Mars is up now, getting fairly high up. Actually, I think Omar was viewing Mars recently. About what time were you looking at Mars, Omar? Do you remember?
The best time that for imaging was right around 12:30, 1 o'clock in the evening.
Right. That's what I was going to say. If you look after midnight, Mars is becoming visible in the southeast part of the sky. And then a couple hours later, Venus rises up. And so as you get towards dawn, Venus is really quite high up in the sky at this point, And so let me scan our questions here. Let's see. Patrice mentions the Star Alberio. Yeah, Alberio is a good one. Does show it's bright enough that it shows colors. You see a yellow and a blue star together. I'm not sure if we'll have time to take a look at Alberio tonight. I think Mark wants to show this galaxy first here. Is this the pinwheel we're looking at, Mark?
Yes.
Yeah.
It's coming in very poorly because it's low, but I'm going to share it anyway.
Okay, sure.
All right. I think Omar has to unshare whatever he's looking at, though.
Oh, yeah,
there
we
go.
go.
Perfect. It's not very impressive because it's low, but the
Okay,
image will
well,
keep stacking, so it might get better.
right. Oh, there we go. Okay.
Yeah, barely
So
see it.
this is the famous Pinwheel Galaxy. Trying to remember, what constellation is the Pinwheel in?
It's Ursa Major. It's right above.
Oh, that's
Dipper.
right.
Yeah.
Right. It's near the Dipper in Ursa Major, and it's called the Pinwheel because it is a spiral similar to our own Milky Way galaxy. And as we look at this, as the camera is stacking up some of these images, again, Mark is taking 20-second exposures that are stacking up.
You can
And
start to see the.
Yeah, I can start to see a little bit of the spiral structure, kind of a little bit of a spiral there.
Right.
Of the galaxy. Those are the arms of the galaxy there.
Yeah, it's coming in. I'm clipping here. Trying to find a setting to make the detail come through.
Kind of see a little
without
bit of
the background.
Yeah. So you see a little bit of those spiral shape.
Right. You could see the spirals coming in here.
Right.
And as this image stacks one after the other, it's adding more time. And the image will get more detail. So it's like the equivalent of opening a camera shutter and keeping it open.
Right.
So as these stack, right now there's 8 of these, and they've been taking 20-second exposures.
8 pictures. Okay. Yeah. Well, that's pretty good for only 8 pictures.
Right. So there's the core, and you can start to see. So this is another this is outside of our galaxy. This is another galaxy.
Yes, yeah. So we're looking outside of our galaxy. This is about, by the way, 20 million light years away from us. So you're looking 21 million years into the past. So it's pretty amazing to think about. Patrice asked, is the pinwheel in Canis Venetizi? It's a constellation called the Hunting Dogs, Canis Venetizi. But the pinwheel is close to the border, I think, but it is in the constellation Ursa Major. So. Okay. So we are running out of time. We've actually been online for quite a while here, and so we hope you've been enjoying this particular program. We'll take a couple more questions. Are there any other objects here that you guys can easily get for us? We did want to try the Eagle Nebula.
Omar, that's you.
In M16, is that possible? Because I know I think someone asked for one of those southern objects.
My southern sky is clouded over right now. Omar, how does yours look? Omar, how does your southern sky look?
You're muted.
There
we go.
I'm actually just getting the roster back up and running, and I'm actually on M51.
Oh, really?
I got on Altair. Sorry. So it's just coming up on the screen, but I just got to center it out.
Yeah, if you want to jump over to M51, that's a very nice galaxy as well.
Sharing.
While you're centering,
when you're ready, and I'll stop.
William had a good question. He's asking if you guys are using focal reducers, and I think the answer to that is yes, I believe, right? Both of you are using focal reducers.
I'm using an f5 focal reducer, but I have the distance, the backspacing. It's f4. So at the end, so I'm at f4.
So what that basically means is he's using an optical device called a focal reducer. It's a lens, and it kind of effectively makes the telescope focal length shorter, so you can see a larger part of the sky, and it's good for photography. You can get some nice pictures with that. And so focal reducers are very commonly used in astrophotography. Susan asked again, where are the two telescopes? One of them is in Morris County, the other is in Essex County. And speaking of which, Robert asks, is there a good astronomy club in northern New Jersey for a beginner? And yeah, we're very lucky that we do have a number of astronomy clubs in the area in northern and central New Jersey. And one way to look for your local astronomy club is to go to a website called uacnj.org. That's the United Astronomy Clubs of New Jersey. It's kind of an umbrella organization for the astronomy clubs here in New Jersey. Mark and Omar and myself are members of the North Jersey Astronomical Group, which is in the Clifton, Montclair area, but there are other clubs around. And so you can look for our website. Our website is njastro.org. UACNJ is uacnj.org. And they have a list of astronomy clubs that are members of that organization. So you can look that up as well. So we are fortunate that we have astronomy clubs here that are very happy to help beginners to get started if you're really interested in getting into this sort of thing. Let's see. Are there any other unanswered questions that we haven't talked about? I'll just scan down my list of questions here. Someone asked, how do you determine a galaxy? I guess the question is, how do you know this little blob of light in the sky is a galaxy? Sometimes you can tell just by looking. When you see a spiral structure like this, this is very characteristic of a spiral galaxy, and so you can tell just by looking sometimes. But if you really want to be sure, you should measure its distance. And if you're able to measure its difference by analyzing the light, that will tell you how far away it is. And of course, galaxies are much further away than star clusters and nebulas in our own Milky Way. Okay. And here's another question that is related to our planetary nebula. Eric asks, well, what happened to any objects that were orbiting those stars? Well, they're probably pretty crispy. The inner planets were probably burned up by the star as it expanded. The other outer planets may have gotten roughed up pretty badly too, but some of them may still be orbiting. So some of those planetary nebula might have planets, sort of dead planets, still orbiting around the central star, the remains of the central star anyway. So that's a good question. And Joy asked a good question: what kind of telescope do you need? Let me put it this way. Let me answer the question in a different way. A lot of people ask us at the planetarium, what kind of telescope should I buy? And one thing that we often recommend, and also people like Mark at the Astronomy Club will recommend, is to get a Dobsonian telescope. It's called a Dobsonian style telescope. And you recognize them because they kind of look like big cannons. And you can get a 6 or 8 inch diameter telescope for a fairly reasonable price. And in some cases, you can get a 6 or 8 inch telescope for less than the cost of a smartphone in some cases, especially if it's an Apple. But you can get a decent 6 to 8 inch size telescope, and you can see quite a few of these objects that we're looking at tonight. Maybe not quite in this level of detail. Light pollution is a problem for us here in New Jersey, and we're always looking for places where we can go to get away from those city lights. Places like the Adirondacks and Pennsylvania, central Pennsylvania, are fairly free of light pollution. Places up north too, even further up north, have less light pollution than we have here near New York City and other populated areas. Let's see. Omar, do you have M51?
Yeah, I'm just tweaking it out a little bit. So give me a second here. I can share what I've got, but it's not optimal yet.
Let's go.
I think we are running out of time here. We do need to wrap up our program.
Yep, no worries.
So let's take a look at it, even if it's not the best view. I know it is low in the sky at this point. I think M51, which is the famous Whirlpool Galaxy, And this is in the constellation Canis Venetizi, so maybe that's one that Patrice was thinking of. This is the famous Whirlpool. And yeah, actually, that's a pretty decent view considering how low it is. It's best seen, I think, in the spring and early summer is a good time to look when it's high up in the sky. Now it's setting over in the northwest. And yeah, there's that beautiful spiral structure. And the interesting thing about the Whirlpool Galaxy here is that it's kind of colliding with another, or has collided with another smaller galaxy. You can see that off to the right-hand side is a smaller galaxy that it's interacting with. So gravity has kind of pulled these two galaxies together, and that's a very common thing in the universe. It's actually how galaxies are formed. Our own Milky Way formed in the same way, colliding with smaller galaxies, kind of gobbling them up and making their material part of them. And so that's how these large galaxies form. Okay. Let's see. So there's M51, also not far from the Big Dipper. So it's a popular object for amateur astronomers there. Okay. And so there's a beautiful view. Actually, let's wrap things up here. A couple more questions here. Jonathan asked, how would you start stargazing? You can get a small telescope. Pair of binoculars is a good way to start. Joining your local astronomy club. Those are all good places to really start. And looking at the sky, just taking a look at the nighttime sky and very slowly learning names of some of the stars, and find familiar objects like the Big Dipper. Start out as something familiar, and then you can jump off into something else something else that might be interesting to you. So a couple of people, both Bob and also Maria, asked about meteor showers. And so actually, let me share my screen one more time here, and we can show you the night sky and talk a little bit about meteor showers. Now, recently, we did have a meteor shower that's named after a constellation that is rising up in the northeast sky. And right now, at this hour, is a little bit low in the northeast sky. And so I'm going to highlight the constellation Perseus here in the northeast. And the constellation Perseus gives its name to a meteor shower, the Perseid meteor shower, which happens in mid-August. The peak was last week. Technically, the shower is still active, but at a fairly low level. We've missed the peak at this point, and so you get a little bit of meteors streaking out of this part of the sky. And so they're coming from the constellation Perseus. That's how the meteor showers get their name. They're named after the constellations they appear out of. And so you might see some streaks of light coming out of the northeast part of the sky. Not a whole lot at this point. Unfortunately, right now for the Perseids this year, despite some of the things that you may have read, I saw a lot of articles saying, oh, this is the best shower of the year. Well, no, actually it wasn't for this year. You always got to think about the moon phase. And this time around for mid-August, the moon was in its gibbous phase, and it was in the sky for almost the whole night. And so it really kind of reduced the amount of meteors seen by quite a bit. And so in some of those articles I read, they mentioned, oh, well, you'll see 100 meteors per hour. Well, no, not really. That 100 meteors per hour is under very ideal conditions. If you have absolutely perfect viewing conditions and you're exactly at the right time of the peak, which we were not for us in New Jersey, if you had those perfect conditions, yeah, maybe then you'd see 100 per hour. But in New Jersey, we don't have perfect conditions. We have light pollution. We had the moon in the sky. The peak was happening during daylight hours for us. And so it wasn't ideal. I'm really looking forward more to the Orionids. The Orion meteor shower and the Geminid meteor shower. Those are probably going to be the two best meteor showers of the year. And those, I think the Orionids peak around October 20th, and the Geminids are peaking around December 12th and 13th. The Geminids are actually my favorite shower. It's the most reliable shower of the year. You get nice bright meteors, and it's visible all night long. As soon as it gets dark, it's visible all the way till dawn. So a great meteor shower that kind of gets short shrift because it's happening in the middle or close to the holidays. And a lot of people don't want to go outside and go stargazing, which is kind of a shame because it's really a nice shower. Any last thoughts here? We are out of time. We do need to wrap things up. And so I want to thank everyone for their questions. Mark and Omar, if you have anything else to add there.
Glad to be able to join everyone else. And
Yeah.
I think we've, given the partly cloudy skies, we've actually been able to tweak out some pretty decent images.
Yeah.
The last one with the galaxy, actually, I realized why it wasn't stacking as well. Is there was a cloud over it. The second,
Oh.
sort of
Yeah,
the second
as we
half
always
of it.
like to say, as amateur and professional astronomers like to say, our telescopes can't see through clouds,
Right.
despite what people might think. And so that can be a problem. Yeah. So thanks, Mark. Thanks, Omar. Thanks to the North Jersey Astronomical Group. We hope that you enjoyed tonight's sky tour, and hopefully we can do this again sometime soon. Keep in mind that our next astronomy program is happening next week, Tuesday, August 25th at 12 noon. We'll be talking about black holes, really fascinating objects, and we hope you'll join us then and ask lots of really good questions about these really bizarre objects out there in the universe. And so thanks once again for joining us. Hope you enjoyed it. Hope you'll join us online for some of our other programs that are coming up. Take a look at the museum's website, newarkmuseumart.org, and check out some of our upcoming programs. You can register for them and find out more information about those programs. And so thanks for joining us, and have a good night. Happy stargazing.